I think yes. Let's start. Okay, so our first problem, here's it. I'll send it in the chat. Take a look and read the statement, and then we'll discuss it. Okay. Okay, the statement is pretty short, so it's just one line or two lines. But let's say it and see if you have any ideas. So, given a binary matrix filled with zeros and ones, find the largest rectangle containing only ones and return its area. So, for example, here we have a binary matrix of size 4 times 5, and we want to find the largest rectangle containing only one. That's it, and return its area. So the largest area of a rectangle containing only ones. So for example, let's take this image. So for example, we have this rectangle is not possible. This is not okay because it has 0, and we want only a rectangle with only ones. We can take a rectangle of size 1 times 1. So a square is also a rectangle, okay? And this is possible, but its size is 1, okay? We can take this rectangle, size is 1 times 2. It's obvious here that the answer for this particular case is this rectangle, okay? 2 times 3, and so the area is 6. So we want to efficiently get the area of the largest rectangle containing ones. That's it. Okay. Any ideas for how to solve it? Anyone want to say something before I start explaining the solution? Okay. So let's look at the constraints. So we have the number of rows and the number of columns are smaller than or equals to 200. So let's look at some approach and see will it fit or not. So what if we brute forced every rectangle? So start at each cell. So for example, we are here at this cell. And then look for every possible rectangle that this cell is the upper left corner of it. So if this cell is the upper left corner of the rectangle we are looking at, then we would be looking at this rectangle, this rectangle, this rectangle, this rectangle, and so on. Okay, so the brute force way is that we go for every cell, we check every cell, and see see if it's the upper left corner of the rectangle we are looking at, and then check every possible rectangle. So this approach will cost us O of n. So let n be the number of rows and n be the number of columns. Okay, so this approach will cost us O of n times m for each cell we are looking at, and for each cell we are looking for every other cell to form a rectangle with, right? So this will be multiplied by n times m. So every cell in this grid with every other cell in this grid. So it will be n squared m squared. Okay. But n squared m squared is too, cannot pass too many. It's 200 power 4. It's a very big number, but we cannot do it. So there is an optimization for this solution that we can make it fit. So here 200 power 4 is strictly 1.6 times 10 power 9. Okay, so it's very close, and we want to make it close to 10 power 7, for example, to make it pass, right? So for this complexity here, O of n times m of n times n times m times m. If we dropped any factor here, m or n, we should be okay, right? So if we dropped, for example, some n, so if we optimized our solution to be O of n squared times m, this should pass, right? Because at maximum, we would make 200 power 3 operations, and this would be 1, 2, 3. So this should be 8 times 10 power 6. So this should be very enough to pass our solution. Okay. So how would we optimize it? Okay, let's say, and if you have any idea, just say while I'm talking, cut me and say I have the idea. Okay. Okay, let's explain the idea for O of n squared times m solution, and this should pass. So we said that we will check for every cell if it's the upper left corner of the rectangle we are looking at. Then we'll check with every other cell in the right of it. So in the right, we would check with this cell and form a rectangle. Or we would check with this cell and form a rectangle here, right? Or this cell and form a rectangle, and so on. And here we would brute force all the other cells. But actually we don't need to get every other cell to form a rectangle, because we are restricted by only the number of ones in the rectangle, right? So we don't want to take any rectangle that is containing any zero. So we will ignore any rectangle that's containing at most 1 0. Okay. So how could we do that? To make things easier, let's swap this 0 with 1. Okay. Okay. So what if so we will do again, check for every cell if it's the upper left corner of the rectangle we are looking at. We will not look for every other cell in the right of it, but we'll do something else. So we will say what is the maximum number of consecutive ones to the right of this cell. Okay, so the maximum number of consecutive ones to the right of this cell is 3, right? So we have these 3 ones. So it's optimal to take these 3 ones with us in our first step here. So in our first rectangle, it's optimal to consider these three ones, and then check. We have here a rectangle of size 3 by 1, right? So then we'll store it. We have a rectangle of size 3 by 1, and then we want to look for a better rectangle. We will not look for every other cell, but we'll do something else. We will go down. So we want to increase the height of this rectangle, right? So we will go down, and while we are going down, we'll check for the new cell. So here we started at this cell, and then we get down, and then we'll check for the new cell. What are the maximum number of consecutive ones to the right of me? We'll find that it's 0. Actually, it's 1 including me. So we only have 1 here, right? So if we extended this rectangle, it can only be like this, right? So we will extend this rectangle to the down here. So consider we extending this rectangle, but we'll find that this one doesn't have any other one to the right of me. So we will erase these right bounds, and then it will be something like this. Okay, and then we'll go down again, and then we'll find that the maximum number here for this cell, the maximum number of consecutive ones is 5, right? But we said that we are considering this cell we are looking at, we are considering it to be the upper left corner of our rectangle. So we cannot also, again, we cannot extend this rectangle to be like this or like this, I think. So we cannot only extend it more than 1, right? Because we have here only 1 and the 0 cut it. So only we can extend the rectangle like this. Okay, and again we'll go to the last cell, and then we'll find that the maximum rectangle we'll find it is 4 times 1, but this cell is the upper left corner of the rectangle. Okay, so we have checked this cell. Let's go to another cell. If we went to this cell, we'll find that the maximum rectangle is 1 by 1, because we cannot extend it any more down. We found 0 here. Okay, so if we check this cell, it's only 1 by 1. But let's check this cell. So this cell, from the first step straightforward, we'll find 3 by 1 rectangle. Okay, and if we went down, we will find that this rectangle, that this cell have consecutive 3 ones. Okay, so this rectangle can be extended and be 3 by 2. And if we want another one down, it's not possible. Okay, so what if we have, so we'll have at the end we'll have something like this. We'll store for every cell the number of, so to calculate the number of consecutive ones starting from each cell to the right of it, we will make an array and store. So we make a new matrix and store for every cell the number of ones to the right of it, the number of consecutive ones to the right of it, including this cell. Okay, so let's start with this cell here. The number of ones at this cell, consecutive ones to the right of this cell, including this cell, is 0, right? And here we have 0 ones. Here we have 1 ones. And here we will have this one and the one to the right of it, right? So here will be 2. Here will be 3. Here 1, 2, 3, 0, 1, 1, 2, 3, 4, 5, 0, 1, 0, 0, 1. Okay, so here's it. So at the end we'll have something like, let's erase this, we don't need it anymore. So let's explain it in an abstract way here. So let's say we are checking some cell here, some cell, okay? And we know that we will check this cell and all the cells to the bottom of it until the end, right? And we will have an array storing the number of consecutive ones starting from each cell to the end, right? So we'll have something like this. So here, okay, we'll have something like this. Some numbers here, 3, 4, 2, 1, 3, 5. So any numbers, okay? 2, 5, 7, okay? And here, if we started at this cell, at the first step, we'll find that it can go 3 steps to the right, right? So here we will store that we have got a rectangle of size 3 by 1, right? But then at the second step, we'll find that it can go 4 steps to the right. But if we extended the rectangle, it cannot be extended more than 3, right? Because I have passed 3 before, and here we have 4. So the rectangle could only be extended um, 3 steps to the right, okay? Because I have passed to 3 before me. So here I found a rectangle of side 3 by 2. So here 3 by 2, okay? And when I reach here, I find that I can go 2 steps to the right. And this is the minimum number of steps to the right I've got so far. So 2 is more than 3 is more than 4. So I cannot go more than 2, right? So the rectangle here will be of size 3 multiplied by 2 again. The height of 3 and the width of 2, okay? So, and if we reach here, we'll find that we can go only 1 step to the right. So the height will be 4 multiplied by 1, okay? But for here, for 3 and for 5 and for 2 and for 5 and for 7, so here we have reached 1 only, 1 steps to the right. So we cannot increase this number while we are going down, right? Because the rectangle cannot be extended to the right more than 1. 1 is the minimum number we have found so far. So here it will be, the size of the rectangle will be 5 times 1, 6 times 1, 7 times 1, because I'm only increasing the height. The width is not increasing. Okay, 8 times 1, 9 times 1. So I found that the minimum, the maximum, the largest into the maximum area for the largest rectangle is here 9 times 1. So the answer here, so if I'm checking this cell only, the maximum rectangle is of size 9, okay? And then we'll do this for each and every cell, okay? And we'll end up checking every cell, which is n times m cells. And for every cell, we'll check all the cells to the bottom of it. So it will be O of n times n times m. That's it, and this should pass. So any question regarding this solution? Anything you before I go to code? If any point you didn't get it, tell me. I'll say it again.
Hi, I have one question.
Okay.
So from previous metrics and this linear metrics that we come up across, I am not 100% clear how do you got these numbers that we are seeing here. So actually this is one question I have, and the second question I have is here we are looking, I mean, let's say we reach at the 3. So here we have 3 ones as you were saying. So, but if you look at, I'm talking about the second tree actually, second tree after 1, the 3.
Actually, I didn't get you. Can you rephrase that again?
Yeah, I was saying the fifth tree that we have from top, fifth tree.
Okay.
Like after 3, yeah. So here, I understood is like there are 3 ones here, right? So don't we have another rectangle which could be of a bigger size, like we have till at the bottom we have 7, right? So can't we have like 1, 2, 3, 5 by 2 or 5 by 3, 5 by 2 basically, because we have a 2 in between as well.
5 by 2. I don't think so. Why you are saying 5 by 2? So of height 5, and yeah, here you mean here 5 by 2.
Yes, because we
Yes,
have 3 here, right? So there are 3 ones here.
yes, okay, that's right. But remember that we are only that we will get to this rectangle later. So we are only considering the rectangles that this cell is the upper left corner of it only.
Okay,
Okay,
I see.
so that's it. And so we'll check for this cell and then again for this cell. And when we reach this cell, we will find this rectangle. Okay.
Okay.
Okay. So what the first question was how to calculate these numbers. This was your first question.
Yeah, first question was like from the previous matrix, how did we come up of here? So are we just putting the number of ones to the right for each
Okay, we'll get to
column?
it. It's actually easier than you think. Let's copy the image here. Okay, so here, how to calculate this number? We will have to calculate this number. We will have another matrix of size n times m of the same size, and then at initially each cell would be empty, would be initialized with 0. Okay, so to calculate these numbers, we will start from the rightmost cells. Okay, so start from the rightmost cells, and 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 it doesn't matter if we started from top or from the bottom, but for each row we'll start from the rightmost cell. Okay, so let's take the first row and calculate this number for every cell. So the complexity that we'll calculate this matrix in should be O of n of m. That's it. So for each cell, we'll take a constant time to calculate. So here, for the rightmost cell here, we'll, since this 0, so we'll put it 0. Okay, and then we'll go to the cell to the left of it, and then if we find, okay, let's say it in another way. So if I find any cell 0, then I'll put the number 0 in this new matrix. Why? Because if I found any cell 0, then there can't be any ones, consecutive ones starting from this cell, right? So this cell is 0. So that's it. Any cell I found 0, then I put 0. That's it. But what if I found 1? So if I found 1, then the number that should be in this cell is 1 plus the number to the cell to the right of me, right? But the cell to the right of me is 0. So here I put 1 on it. Okay, and here for 0 we put 0, and here we'll put 1. But let's look at the second row. So I said that if I reach any 0, I'll put 0. And also the rightmost cell, I'll put it as it is. So here 1, I'll put 1. Because there is no any consecutive ones to the right of this one. Okay, it's the rightmost cell. And then I'll go to the left. This is 1, not 0. So I'll have to put the answer of it 1 plus the answer of the right of the cell to the right of it. So it should be 1. Okay. So 1 plus 1 equals 2. Here we found another 1. So this should be 1 plus 2, which is 1 plus the number at the cell to the right of me. So it should be 3. And then I'll continue. Here I found 0, then I'll put 0. And here 1, I'll put 1 plus 0. Here 1, I'll put 1 because it's at the rightmost. Here another 1, I'll put 1 plus 1, which is 2. And here 1 plus 2, which is 3. And here 1 plus 3, which is 4. 1 plus 4, which is 5. And here 0, 1, 0, 0, 0. So I ended up with two cases. If I am standing at any 0 or at the cell at the rightmost, so if I am standing at a 0 or at the rightmost cell, then I'll put the number at this cell as it is. So if it's 0, I'll put 0. If it's 1, I'll put 1. Okay, if it's at the rightmost. And if it's 0, I'll put just 0. Okay, otherwise it is 1 and it's not at the rightmost cell. Then I'll just put the answer of it equals to 1 plus the answer of the cell to the right of it. Okay, did you get it now?
Yeah, no, I understand that part, but the final values that you showed, right? 3. So that I didn't got it. Like, how did you organize those values, right? How did you, from this numbers, how do you came up with that linear values?
I didn't quite understand you. So how
No.
did I come
So
with this approach or what?
no. My question was, like, I got this calculation that you showed just now, but after this, like, you created one linear what do you say, matrix, right? Which was like single column where you had like values like 3, 1, 2, something like that, right? So
Yeah,
how did
no,
you from
yes,
this one
say,
to this one?
okay. So you are wondering how can I store these values, right?
Uh, yeah, actually, was just
No,
before this matrix that you were showing one
like
single.
I think he is asking how did we get that let's say for row 2 like 0 1 2 row 2 we would have got the maximum element as 5 uh, 0 1 2 the third one I said by indexing I said 2
So you are saying
so
what at the second row?
the third one third row
So the third row.
third row if we
Okay.
see that will be having 5 right to the left most
Yes.
it will be having 5 so
Yes.
let us consider the row 1 it will be just 1 am I
Yes.
right
Yes.
but previously when you have written that maximum elements there we found it was written with 3 4 something like that so how did
Yeah,
we come up with that is what he's asking.
yeah, that's what I was trying to ask. Yeah. Yes.
Okay, so actually after we calculated this new matrix of the sizes of consecutive ones, we will just make another loop and check for every cell. So we'll make another loop to calculate actually, and then check for every cell. We will store value of the height we are standing at now. So at first we will be standing at height 1 for this cell, and then while we are going down, the height will be increasing, right? So we'll have a counter that will be increasing, and then we'll go down. The height should be increasing, and also we have stored values of the number of consecutive ones. So while we are going down, we have a value storing the height. We'll find at the end that the height is 4, and the minimum value of a width we could get, and actually the maximum value of a width we could get is 1. So that's how we calculate it. So it's a new, we calculate it in a separate way, and we'll not we won't make any other array for storing the heights. We are just going down and then increasing the height in some counter. Did you get it now?
So,
Or
so the maximum heights of row is first considered, and later we are considering the maximum weight of the column also. So now row 1 will be having 4 in its leftmost.
yes, so actually we are brute forcing on
Mhm.
the left edge for the rectangle. So what we are doing here, so technically what we are doing here is checking the left uh, all the left edges for every possible rectangle. That is literally what we are doing. We are checking the left edge for every possible rectangle. That's it. So here we are checking if left edge is like this, or it's like this, and then we'll do something like this, and then we'll do something like this. So we are checking every left edge, every single left edge of every size in this matrix, and for every left edge we know the maximum width we could get with the new matrix we calculated. Okay, everything's clear.
Oh,
If it's not clear, say what exactly is not clear.
yeah.
Okay.
I'm not clear on the final calculation that we had. So I am clear on the calculation that you showed on this metric, but the final calculation that we had, right, which we built up. Can you, like, I mean, if possible, like, can you show that, like, the final
So actually,
calculation that we
I'll code it, and it will be easier for you to understand.
did?
But first, I want to make sure that you understand the concept. So if we are just drawing and thinking, how could we do that? We will see now how we could implement that. But do you understand the concept of checking every edge for every possible rectangle? So the concept, the thing that we are doing here is checking for every cell. If this cell, if the upper left corner of the rectangle, then we are checking every possible edge starting from this cell. So here, if I'm at cell number 1, we check this edge, then this edge, and then this edge. Okay, now we finished this cell, and then we'll go to the second cell, and then we'll check all the edges. Okay. What is that?
So this calculation, right, that we have here, can you show us that one time?
Say that again, sorry.
The one that you just now showed, like 3, 4, 2, 1. That the one just now that came up on the screen.
So can you ask the question again? I didn't get you.
There was some calculation that the values that you showed, right? 3, 4, 2, 1.
Yes.
Yeah. So that how we are coming up with that. Maybe I'm not clear. I'm not sure about this, but
Okay, so I'll say that again here. How we are calculating the values. 2, 3, 4, 5, 1, 3, 5, 2. Okay. So here I'm considering only one column. Okay. So for sure, if this is 2, if this cell is storing 2, then I'm sure that this cell is storing 1, right? And this cell is storing 2, then 3. Because the number of consecutive ones starting from this cell is 5. Then I'm sure that there are another 4 cells to the right of me, right? Did you get? Are you getting that?
What are these values denoting? Right, 2, 3, 4, 5.
These are the values. So of course, these are the values of the other matrix that I calculated, because I only have 2 matrices: the original matrix,
right,
and the new matrix that I calculated in it, the number of consecutive ones to the right of every cell, including this cell. Okay. So here I stored 5 because the number of consecutive ones to the right of this cell, including this cell, is exactly 5. So if this cell is storing 5, then I'm sure that this cell should be storing 4.
okay,
Right? Okay. So here I'm just considering only one column, but I'm sure that the other columns will be like this. Okay.
Shouldn't you start with 1? Like when you're starting with 2, 3, 4, 5, shouldn't you start with 1?
Should I start with 1 from where?
At the top, like you're writing 2, 3, 4, 5, right? The first one should be 1, right?
I'm not sure I got you. So I'm just writing any random values and they could be true. Okay.
I see. It's not just random values, right? It's another actual values. Okay, got it.
Okay. Okay. So here I'm just checking any random column, okay? But I know that the other columns will be something like this. Okay. And here I don't know yet because here this is 0 and I don't know if this is 1 or 0. Okay. So this could be 1 or this could be 0. But it's not important here. I'm just checking this column, this particular column. Okay. And then I'll start from this cell, for example, and then go down. And while I'm going down, I'll be storing the maximum width I could get. Okay, so here I'm at height 1, and the maximum width I could get is 2. And then I go down. I'm at height 2, but the maximum width is only 2. I cannot go of width is 3, right? And then I go down of height 3, and the maximum width is 3. So actually, the maximum width I could reach is the minimum between all the widths before me. That's it. So if I'm standing at this height, so it's of height 4. And what is the maximum width I could reach? It's the minimum between all of these widths. So it should be 2. So the maximum width I could reach is 2, because the minimum width of these 4 numbers is 2. That's it. And then I'll go down again, and at the end I'll find that I cannot go to a width more than 1, because I have here 1 and it's bounding me. I cannot go more than 1. Okay. And then this height is very big, I don't know, 10 times 1. And then after we finish this cell, we'll go to a whole new cell. So we'll start, for example, with this cell. And
Is this values are consecutive ones for each row?
Are these values what? Sorry?
Are consecutive ones for each row? This 2, 3, 4, 5, 1. What are these values?
So these values are the values corresponding to this column in the new matrix we formed. So we formed a new matrix of exactly the same size. It will be something like this. Okay, so this is a new matrix.
Okay.
And this matrix will store at each cell the number of ones to the right of it, the number of consecutive ones to the right of it, including this cell. So for example, here 1, 2, 3, 4, 5. So here I'm just taking one column. So like this, like this column.
So this is like one specific column in the matrix where the count of the rectangle, the count of ones, right?
Yes, that's it. That's one specific column, and I'm going through all heights. Okay. Okay. So the one who's asking, did you get it or not? See if there is any point you didn't get here at the calculations.
So which column we are having this? Like you said that we are taking for one specific column, right? So here in this matrix.
These are random values, right? These are not specific to these particular metrics, right?
Yes, of course. These are random values because here we have 5, 4, 3. This is a very big matrix. Okay.
I see.
That's it.
So this is not corresponding to this number.
Yes, these are random values.
Okay.
Maybe you can try to explain with this example.
Can we run up with this current example? That would be better to understand.
Yeah, even I'm not. It's not clear to me to understand, to map between this random number with the actual matrix. So it will be good if you explain with the actual matrix which you have it in the board.
Okay. I just could copy this matrix again, and okay, let's erase everything here. And then we'll duplicate this matrix, and it should be easy to visualize. And I was saying this number, I was putting these numbers at the top of the matrix to make it clear. But here, okay, this image. Okay, so we will have some matrix here. This is our original matrix. Okay. This is our original matrix, and we will make a new matrix of the same size, but it doesn't have any values. So it's empty. Okay. Empty means that it's a random value. We didn't assign it yet. Okay. So here we created a new matrix of size n times m, and then I said that we will start to calculate these values starting from the rightmost cell at each row. Okay. So it doesn't matter if I started at the for this row or this row, but I'll start at the top. Okay, so I'll start at the top and calculate like this, like this, like this. Okay, so let's calculate the value of this cell. So I have here two cases. Okay, let's say the two cases here. So if I encountered any cell of value 0, if cell value equals to 0, then I'll assign the number at this matrix to 0. Okay, so let's call this matrix ones to the right. So ones to right will be equals to 0, but 1 to the right of this cell. Okay, this cell. So to make things easier, we'll make here a matrix called ones to right, and it will be of size n times n, and it doesn't have any value yet. And I loop, as I said, starting from the rightmost cell at any row. So let's say we'll start from the top to the bottom, and for each row we'll check the rightmost cell. So if I, at any point, I encountered a cell with value 0, so if ones to right, no, if the main matrix, so if the main matrix have a value, so here I'm standing, for example, at some index ij. So if it has a value of 0, then immediately ones to right of ij will be equals to 0. Is that clear? Because if I am standing at a number 0 here, then I'm sure that I have no other ones. So if I'm standing at 0 here, then this cell cut any consecutive ones. Okay, so I want to count the number of consecutive ones, including me, to the right. Okay, so if I found any cell of value 0, then I'll set this the value of ones to the right equals to 0. Okay, and we have another case. If mate ij, not mate ij, if we are standing at mat ij and j equals to m, so what does mean j equals to m? So if I'm standing at some cell and the column of this cell is the last column, so that actually means I'm standing at a cell at the rightmost, so these cells. So if I'm standing at a cell at the right, then I'll initialize the value for the new matrix ones to right ij equals to the value of this cell of matrix ij. So if it's 0, I know that I initialized it before, and if it's 1, then I'll put 1 because there is nothing to the right of it, right? So here are these only two cases, and else. So here, this else, if it's not this or not this, okay? So else, we'll just make ones to right equals to ones to right, so here ij. So ones to right ij equals ones to right ij plus 1. So the number of consecutive ones in this cell equals to the number of consecutive ones at the cell to the right of me plus 1. That's it. And why? Because if I'm standing at any random cell here and it's not 0, because I checked this case before, so else if this is not this, okay? So I know that this cell is not 0, and I know that this cell is not at the rightmost, right? So it should be 1. So it's actually 1. So for example, if I'm corresponding to this cell here, then I'll store 1 plus whatever value at the right of me here. Okay, So let's fill this matrix as the way I said here. So I'll start at the rightmost cell for every row. So starting from this row, if I encounter 0, then immediately I'll put 0. Okay, here 0, here 0, immediately. And here I found 1, then I'll put 1 plus 0, so it will be 1. Here 0, I'll put 0. Here 1, then I'll put 1 plus 0, 1 plus the value to the next of me. And here we are at a value at the rightmost, so it's 1, then I'll put 1. And here we'll find 1. Then the value of this cell will be 1 plus the value to the next of me, of the cell to next to me. Then I'll put 2. Here it will be 1 plus 2, which is 3. Here 0, I put 0 immediately. Here 1, 1. Here I'll put 1, and then 2, and put 3. And here 4, because 1 plus 3. 1 plus 4 is 5. And here 0, I put 0. Here 1, I put 1. And here 0, 0. And here 1. Tell me if you don't understand any case of the cases we said here. Okay, so these are the only 3 cases. Else here is corresponding to else if it's not this or this. So this is not official code yet. We write the code. But here, if it's not this or not this, then we'll just initialize it with 1 to the right plus 1. Tell me if anything you don't understand here. Everything's clear?
Yes.
So now, yeah.
Yes,
So now
please.
the random number. So earlier you showed the random number. So instead now it will be 0, 0, 1, 0, 1, right?
Yes.
Okay.
Okay.
So
What
0, 0,
were
1,
you
0,
asking?
1, 1, 2, 3, 0, 1, like that.
So are you asking?
Yeah, I was just verifying. So it will be like 0, 0, 1, 0, 1, and then 1, 2, 3, 0, 1, 1, 2, 3, 4, 5.
Well, which are you talking about?
The random number that you were showing us before. So they will be just transforming to each row, but in the column manner from right to right, right?
Yes, but I didn't get you exactly, so I don't know what you are talking about exactly. But here, tell me if everything is clear about this matrix, and if you are verifying thing,
Yes.
just tell me what are you verifying exactly to make sure.
No, this matrix I'm clear actually.
Okay.
I was just verifying that the random numbers that you were listing before, right, in a single column.
They were of a single column like this, for example. So this is a single column, 0, 0, 4, 0. I was writing a random column like this column. And here I found that, and here I found that if this is 5, then I'm sure that this is 4, I'm sure this is 3, 2, 1. But if this is 1, actually, if this is 0, then I'm not sure what this value is. Could be 3, 1, anything. That's it. Okay, so let's see how could we code this. So everything is clear here about the visualization?
Yes.
Okay, good. Okay, let's erase this and start coding. So we'll copy paste this as it is, the class. So here at leetcode, we have a class solution and the function that the judge will call to get the return value, and this should be our answer. Okay, so this function we got the matrix in it, and then we should return the answer. Okay, so here I'll just code the function immediately. I will not take any input or put any output. I'll just return the value. Okay, this is how leetcode works. So here I have matrix mat. I want to initialize the values of n and m to make things easier. So At some example here, there is a metric, there is an empty matrix, and we return 0. So not to make things go wrong, I'll check if the matrix is empty, then I'll return 0 immediately. Okay. Otherwise, I calculate the values of n and m. Okay. So n is the number of rows, so it will be matrix dot size. So matrix is a vector of chars. Okay, like this. So here we have 4 rows and 5 columns. And here we have 4 vectors corresponding to rows. And for each vector, we have 5 characters corresponding to the number of columns, right? So n should be the number of vectors in the matrix. So n is the number of rows equals to the number of vectors. And m equals to the number of characters in any vector of those vectors, okay? So n equals, for example, we are checking we are getting the first vector, the size of it, okay? So the number of columns is the number of characters in any vector. The number of rows is the number of vectors. So here that we have n and m, we could initialize the new matrix. So let's say a smaller name, one's right. Okay, in terms of m. So here our new matrix called one's right nm. And then we want to calculate the values at each cell here. Okay, so we'll loop for every cell in the matrix and then calculate. Okay. So here I said that I have 3 cases. I put them at only 2 ifs. So at 2 cases. So if mat of I of j equals to 0. So if matrix of I of j equals to 0, or j equals to m minus 1. So m minus 1 corresponds to the last column. Okay. So if I am standing at 0, or I'm standing at the last cell, then I'll put the value at this cell as it is. Okay. So if I am 0, then the value should be 0, and if I'm 1, then the value should be 1. That's it. So one's right ij equals to mat ij. So how can I put an integer here? We have character, right? So I cannot make it just like this. One's right ij equals mat ij, because one's right takes an integer, and here matrix takes a character. Okay. So if I want to get the value of this character, the real value of it, so if I have character 0, so this character have an ASCII code, right? But I don't know what its ASCII code is. So I just, to know what is the real value of this character, I'll just make it minus 0. That's it. Okay. So if I'm here at character 9, for example, and I don't know if it's exactly the real value of it is 9. So how to store it in an integer here? So I'll just make it minus 0. So 9 in the ASCII minus 0 in the ASCII will give me exactly 9, right? Because and 0 in the ASCII minus 0 in the ASCII will give me 0. So to store it as an integer here, I'll make mat ij minus 0. Okay, everything clear? Okay. So here, this is our first case that we will put the value as it is. So else I know that, so if I didn't go at this f, then I know that I'm not standing at 0, okay? I'm standing at 1. And also I know that I'm not at the rightmost cell. So I know that there is a cell to the right of me and I'm not 0, okay? So just I make one's right ij equals to once right I j plus 1. Okay, I finished calculating the values for this matrix. Tell me if you have any question. Everything. Oh, say.
Yeah, at this point haven't calculated the value of j plus 1, right? It will be calculated in the next part. So how are
Sorry,
we?
what did you say? Calculating what?
Now, at this point, the value of j plus 1 isn't calculated yet. That will be calculated in next class, right?
The value of k plus 1.
J plus 1, the last point.
J plus 1. Yes, at this point it is already calculated. Oh, sorry, I did something wrong. So I should
You have
start.
to come right side to
Yes.
left side, right?
Yes, you're right. So I should start from the right side. So j is greater than 0. And here for the rows, it doesn't matter. Okay, yes, you're right. So here I finished calculating this array, this matrix. Everything is clear, right? Okay, make sure that you understood these cases.
It should be j minus minus.
J minus 1?
No, the loop. J, it's not j plus plus, right? J minus minus.
J minus minus.
Yeah.
Yes, okay. Okay, so let me check. Yes, okay. Okay, so let's.
Sorry, one more
Yes,
thing.
say.
So here, like at line number 20,
Yes.
we are assigning the value at j plus 1. Shouldn't it be like the value on the right, and we have to add 1 to that value, right?
Yes, so j corresponds to the column, and I'm saying that I'll get the value of the cell to the column in the next to me in the same row. So the same I and the right column. What's the
Yeah,
problem
and
here?
you have to increment this, right? Plus 1, you have to do it, right?
I'm doing what?
You need to increment it, right? So we know that it is not 0, right? And it is not the rightmost column.
Yes. Yes,
So
yes.
you have to do plus 1, right? Yeah.
Yes, I'll do plus 1. Sorry. So I was explaining the idea, but things got wrong here. Okay. So I think the idea is clear here.
If any matrix, hello.
Yes, hello.
Yeah. If any matrix has value as 1, which particular trace will be executed?
If any matrix have a value of 1, I didn't get you. What does it mean?
So if the mat of ij is equal to 1, right?
Yes, okay.
Then it will execute the else clause.
So if it equals to 1, then we have two cases. If it's the rightmost cell, then it will go here and it will put it as it is. But if it's not the rightmost cell, then it will take the value of its right cell plus 1. Okay.
Okay. But maybe we first need to initialize that one right matrix, right?
But here we initialize it already because I'm just here checking the first if I am at the rightmost cell, then I'll initialize it. So I'm just putting it the value as it is. So if I encountered 1 at the rightmost cell, I'll put it 1 here.
Okay. Got it.
Okay, good. So since we want to get the maximum rectangle across all rectangles, so we'll have a global answer here and we'll set it to 0, and then we'll maximize it as we go through rectangles. Okay, so here we said that we will loop through each and every cell, and then check every possible edge that this cell is at the top of it. Okay, so again, so here I'm standing at cell ij, right? And here I'm standing at cell ij and I want to go right. And at each time I increment the value of my height. right? Then, so I'll tell you, we will calculate the height without setting a value here, but we are here at this cell, and if I am at some particular if I reached this cell, I know that my height is 3, right? And I want to know what should be my width. So my maximum width should be the minimum width between me and all the widths I passed before, right? So it should be 1. So here I'll store value called width. Is that how it's wrote?
Can you please tell that concept again? How you are calculating that min width?
How I'm calculating that min width? Okay. So here I'm looping just at each cell, and here I'll go from this cell to the bottom, okay? And I'll store some value called width, and it will have the minimum value of all the widths I have passed before. So that means that at the start, my width value should be, so let's make this random column to make things easier. We have here a random column. Okay. This column doesn't correspond to anything, okay. Okay, so here I'm standing at this cell, for example. So while I'm going down, I'll have some value called width, storing the minimum width I encountered so far. So at the first cell, my width is 2, right? So I'll go down. So I've encountered another width of 3, but it's not smaller than 2. Then my width is 2. So I want to make a check of the pronunciation of width. Okay, that's right. Okay, so here, so this corresponds to the width I encountered so far. Okay, so here my current width should be 2, and then I go down. My minimum width is again 2, and here 2.
So so you got these widths by calculating the consecutive ones towards right?
Yes.
Okay.
Okay, so this is how I ended with the value of width. So the value of width ended with 1, and here 1, here 2, here 2, and so on. So where the width is never increasing, it's just decreasing. Okay, so I'm just decreasing it as I'm going down. That's it. Did you get it? Who was asking?
Yes.
Okay, so let's initialize width to be very big. Why? Because I am decreasing it while I'm going. So I'll initialize it to be very big, and when I encounter any width, it should be decreased to this width, to the minimum. Okay, so this is a very large value, and then I want to go down. So I'll start from cell I, which is the number of row, and then go down until until n. Okay, so I'll start from I. So for int k, for example, equals to I, k is smaller than n, k plus plus. So I started from I, and then going all the way down until n, and then updating the value of width and calculating any new answer if possible. Okay, so here I want to minimize the width, so I make width equals to minimum between width and ones to the right of k and j, right? So the number of consecutive ones to the right of this cell at row k and column j. Okay. And here, since I have the variable width is ready, then I'll just update the answer. So answer equals to maximum between answer and, So I want to make width times the height, right? So what's our height? So I don't have to store a value for the height because I know that I'm standing at row number k, and my first cell, so my uppermost cell, is at row number I. So my height should be k minus I plus 1. So this is exactly our height. Okay. So now we calculated the answer. That's it. Everything's clear.
Why is height k minus I plus 1?
So let's take an example here. So here, these are the number of rows, okay? Row number 1, row number 2, row number 3, row number 4. So if at my main loop here, I'm standing at cell number 2, and I went down with k to cell number 4. So what should be the height? Can you tell me? So the height should be, so this height is 3, right? We know that this height is 3. So this is 4 minus 2 plus 1 equals 3. Okay, so I'm taking the number of, so let's make it abstract here. So I am taking from my current row, I'm taking the difference between my current row and my last row, my first cell in the row, and adding 1, which corresponds to this cell. Okay, so if I have two numbers, 7 and 10, and I want to know the number of elements between 7 and 10, including 7 and 10. So if I have two numbers, 7 and 10, I want to know the number of elements between 7 and 10, including 7 and 10. Then I'll make 10 minus 7. 10 minus 7 will be 3, but I excluded 7 this way, right? So 10 minus 7 will be 3 elements, 10, 9, 8. Then I'll add 1. Okay. Are you getting it or not?
Hamad, I have a doubt here. So if we are encountering a 0, we can break it over there, right? Anyway, it will not count further.
Yes, I can break it, but yeah, I can break it, but it won't matter in the answer. So to make a clean code, I cannot write it, but if you want, we can write it. Okay. So say.
Yeah, if you have 100 rows, and if the second row is 0, then we don't have to count for all the way down, right? It will not count for the rectangle.
Yes, it won't differ in the answer, but we can make an if. But if I'm solving this problem and I want to calculate the exact the overall complexity, it won't matter in the complexity, but of course it will matter in the time, in the real time. Okay, so yes, I could make something like this. So if mat I k of j equals 2, 0, I could break, right? But as I said, it won't matter in the answer. Okay. Any other questions? Anyone have any other questions?
Hey, can you tell me why are you actually doing width into k minus I plus 1?
K minus I plus 1. Okay, so let's take another simple problem here to make things easier. So if I'm saying that I have I have 10 elements arranged in a row. Okay, so I have 10 elements arranged in a row, and these elements, so I have these elements are numbered from 1 to 10. Okay, so I have 10 elements in a row and arranged from 1 to 10. Okay, let's do this. And if I told you that I want to know the number of elements between, so these are 10 cells, okay, numbered from 1 to 10, and each cell containing only one element. Okay, so we have here one element at each cell, and these are corresponding to the indices of these elements, and this array corresponds to the number of elements in this array, or somehow. Okay, so I want to, if I told you that I'll give you x and y, x is more than y, x and y, and x is more than or equals to y, and I want you to calculate the number of cells between x and y inclusive. So I want you to print to tell me the number of cells between x and y, not number of cells, number of elements between cells x and y inclusive, including x and y. Do you understand what I'm asking here? So I'll give you two indices, x and y, okay? Let's say I and j to make things easier. I'm telling you that I is more than or equals to j. These are just two indices. I'll be giving it to you, and I want you to calculate for me the number of elements between I and j inclusive. So how could you do that? How could you calculate it? So if I
j minus I plus 1 is what you're saying.
Yes, so it's working, but it's not just I didn't just say it like that. So it's working for a reason. So if I want to know the number of elements between j and I, if I subtracted I from j, then now I have the number of elements between j and I. No, I have the number of elements between j and the element after I. Okay, so what I did here, j minus I is, so let's say I equals to 5 and j equals to 7. Let's say 10. Okay, and here I equals to 7 again. So I'll copy this array here, and if I say j minus I, which is 10 minus 7, then I did something like this. I removed 7 and all the numbers before it. Okay, so 10 minus 7 equals to this, exactly 3 elements. So I made something like this. Okay, so 10 minus 7, I removed from 7 to the first, but I want 7 with me. Then I'll just make 10 minus 7 plus 1, which is this. Okay, that's it. So if I want to know the number of elements between I and j inclusive, then it's j minus I plus 1. And for our case here, we have cell, we are for our case here, our first cell is I, and the cell we reached is k, right? And we know that k is greater than or equals to I. Okay, k is to the bottom of I. So if I want to know the number of cells between k and I, then if I made k minus I, then I remove I, then I will be removed with me. Then I want to make plus 1 to add I. Okay, did you get it now?
Yes, thanks.
Okay, all right. Okay, I think everything should be working here. Okay.
Can you go to the original matrix where you have drawn?
The original matrix, what?
In the
Okay.
drawing board, right? You have the drawing board.
Yes. So what do you want in the original matrix?
Yeah. So in this case, if we calculate the width, right, for the first row, it will be 1. Second row also it will be 1. Third row also it will be 1. Fourth row
Yes.
also it will be 1, right?
Yes.
Okay. So
Okay. Mm.
so in this case, like so width will be 1 into k minus I will be the third row, right? Like the third row.
Can you say that again?
So how actually the width is helping us to calculate the total number of rectangles.
So here we are looping at only one rectangle at a time. So
Okay.
the width corresponds to the minimum width we can reach for this particular rectangle. Okay, so we have now reached one width and one height. So the height is k minus I plus 1, and the width is width. So this rectangle is exactly of size width times k minus I plus 1. And then for the next loop, yes, we will reach, for the next k plus plus plus, we will reach another height and possibly another width, and we'll calculate another rectangle again. Okay, so what was your question here, or is that clear? So say if some point is not clear to you. Hey, are you here? So you left or something. Okay, so everything's clear, I guess. Okay, let's try this code. Let's run it. Hopefully there are no bugs. Okay, so the expected is 6 and our answer returned 6. Okay, I'll submit. But let me check the last time before submitting if there are any bugs. Okay. Okay, let's submit. Is it this my code? Yeah. Okay, let me give you the submission link. But I want to check if it's working for you or not. Then I'll open. Okay. So do you all have LeetCode accounts or not? Anyone
Yes.
here? Okay.
Yeah.
So this submission should work only if you have LeetCode account. You could see it. Okay.
Are you sharing the link?
Yes, I shared it in the chat now. Please check if it's working for you in your account. Okay. If not, tell me and I'll paste it to you in another link. Okay. Okay.
It is saying 404 submission not found, page not found.
It's not opening in the same form.
Right. It's not, I think it is not. Can
Okay,
you
no
just
problem.
place in some shared place?
Okay, no problem. I guessed that. Okay, here's the code again. In the chat, sent it, pestbin.com. So before I move to the next problem, anything you want to ask in this problem? The last time? Nothing? This problem is clear? Okay. Let's move to another problem. Let's take this problem. I'll send you the link in the chat. Take 2 to 3 minutes, read it, and then think about it. We'll discuss it.